Hello my dear students, in the last class we completed two chapters, that is chemical reaction and equation and periodic classification of element. In this class we are going to discuss about one of the important chapter in chemistry part, that is carbon and its compound. It nearly consisting of 5 to 6 marks in your examination. Let us start with that chapter. So students, in this class we will go through that carbon and its compound. It is in the part 2 textbook, this is the first chapter. So we will move on to this carbon and its compound. Before going to this carbon and its compound, first the thing, what is meant by carbon? You know that carbon is the element which having atomic number 6. So there are 118 elements are there in periodic table. Among 118 elements, why we are studying this carbon only? Why we are not studying hydrogen? Why we are not studying oxygen? Why we are studying only carbon only means carbon is such an important element in our day-to-day life. This carbon is one of the important thing. Why? Because the food what we are eating, that contain carbon, that carbohydrate, that also contain what? Carbon. So the fuels what we are using in our day-to-day life, the fuels are whatever it may be, either petrol, diesel, the kerosene or LPG, these things what we are using in our day-to-day life, they all contain what? Carbon. So that's why carbon is such an important element in our day-to-day life. So for that reason we are studying this carbon. For our home what we are using electricity, that electricity will come from the burning of the coal. The coal is nothing but carbon. So this carbon, how much important in our day-to-day life means this. In the absence of carbon, how in the absence of oxygen we can't survive, in the absence of carbon we can't survive our life. So occurrence of the carbon, where carbon will found means carbon present in atmosphere, so that is present as CO2. Maximum of the carbon present in the atmosphere, that is present as CO2, and also some of the carbon present in the earth crust as carbonate form. As the carbonate form, either it may be present in the form of salt also. So that is your what? Presence of the carbon. In the coal form is there, that is also present in earth crust only. So this is all about your what? A carbon. Then in this carbon only, there are two allotrope forms of carbons are there. Actually, allotropy means the same compound, same element present in two different form. The carbon present in two different form. The carbon present in two different form means what are the two different, or what are the two allotrope forms of carbon means one is diamond, one is graphite. Graphite and diamond are the two allotrope forms of carbon. One more is there, that is called as fullerenes. Fullerenes is a football-like structure. It consisting of 60 carbon. The arrangement of the 60 carbon in the shape of a football, that is called as fullerenes. That is also one of the allotrope form, but mainly there are only two allotrope forms. That is, one is diamond, one is graphite. What is the difference between diamond and graphite means the arrangement is completely different. Each carbon is surrounded by 3 more carbon, then it is called as graphite. Each carbon is surrounded by 4 more carbon, then it is called as diamond. Like that things are there. So this is a small introduction about your carbon. Then in the next slide we are going to study about the bonding in the carbon. What type of bond carbon will be form? The carbon will form always covalent bond. You studied in your lower section ionic bond and covalent bond. Ionic bond means if the exchange of electron, the transfer of electron from one metal to another non-metal, then it is called as ionic bond. The bond formed between two oppositely charged species is called as ionic bond. But carbon will never form ionic bond. The carbon is always form covalent bond only. Then what is meant by covalent bond? In the examination, define covalent bond. This one is very important. Why? Because the covalent bond definition, the covalent bond is defined as the sharing of electron. The bond formed by sharing of electron, such bond is called as a covalent bond. Keep in your mind the bond formed between or else bond formed by sharing of electron. Bond formed by sharing of electron is called as what? Covalent bond. Here carbon having atomic number 6. Carbon atomic number 6. In your textbook they mentioned beautifully. What they mentioned means carbon atomic number 6. If I distribute the electron, K shell will get 2 electron, L shell will get 4 electron. L shell will get what? 4 electron. When K shell is get 2 electron, L shell is ready to get 4 electron. It required 4 more electron to get octet structure. It required 4 more electron to get octet structure. Then what possibilities are there? Carbon, either they have to donate the electron to get a completely filled shell, or else carbon ready to gain 4 more electron. If it donate 4 electron, then it will become C4 plus. It is not possible. Why? Because carbon is not have that much of energy to donate that 4 electron. One more possibility is there, that is carbon must should take 4 electron to get octet structure, but carbon, if it gain 4 more electron, the 6 proton, the carbon atomic number 6, so atomic number 6 means number of electron also 6, number of proton also 6. 6 proton can't hold, already 6 electrons are present. If it gain another 4 electron, then the number of electrons will become 10. The 6 proton can't hold that 10 electron. That's why C4 minus is also not possible. Carbon never donate the electron, never gain the electron. The only one possibility is there, carbon is bond only by sharing the electron. That's why carbon form always covalent bond. So covalent bond means what? The covalent bond is defined as the bond formed by sharing of the electron is called as covalent bond. So next we'll move on to the formation of covalent bond. How the covalent bond will be formed? Definitely one question will be there in examination, either for 1 marks or 2 marks. How the bond formation will be takes place? The water what we are drinking in our day-to-day life, that is also covalent bond. The H2 and oxygen is formed by covalent bond only, by sharing of the electron only the bond is formed. By the electron dot structure, the question will be arise in our examination from the draw the electron dot structure of any one compound. They will mention methane, water, carbon dioxide, like that questions will be there in your examination. For that reason I am going to explain 1 or 2 example related to formation of covalent bond. You may observe here formation of single covalent bond, that is H2. Why we will write H2 means it is a diatom. It is an diatom, it never present. If I write H, then it is wrong. H2 is the what? Diatom. Hydrogen, you may observe here, hydrogen consisting of 1 electron. There are 2 hydrogen in H2. This hydrogen consisting of 1 electron, this hydrogen consisting of 1 electron. Both will not donate the electron, they will share the electron. When they share the electron, in between hydrogen and hydrogen, the covalent bond will be formed. Then it forms what? H2. The only one thing is there here, hydrogen. There are H2 consisting of 2 hydrogen. Both are unstable. This hydrogen is also unstable, this one also unstable. Both are wanted to become stable. Either they will never donate the electron. So if it donate the electron, it not have any electron. If suppose this one donate, it not have any electron. That's why they will share the electron. After sharing, they will form single covalent bond. Then after completion of this one, next one more example for the formation of covalent bond is, that is oxygen. Oxygen O2, it is also diatom, it forms a double covalent bond. They only given. So oxygen atomic number 8, if I distribute the electron, K shell will get 2 electron, L shell will get 6 electron. So O2, so here only they mentioned atomic number 8, electron configuration 2 and 6. They are definitely outermost shell consisting of, that is L shell consisting of so 6 electron, this oxygen 6 electron, this oxygen 6 electron. If it donate 2 electron, it will become octet structure, but this will not become stable. For that reason, they will share the electron, these 2 electrons and these 2 electrons. From this oxygen, these 2 electrons, from this oxygen, these 2 electrons will be share and form double covalent bond. That is what? O2. O2 consisting of what? Double covalent bond. In the same fashion, the nitrogen will form 3 covalent bond. Why nitrogen will form 3 covalent bond? Means nitrogen having the atomic number 7. Nitrogen having the atomic number 7. In its outermost electron, if I distribute, K shell will get 2, L shell will get 5. So nitrogen in their outermost shell, it consisting of 5 electron. This one also consisting of 5 electron. They will share the electron. So these 3 electron from the nitrogen share with these 3 electron. Then this will become what? Nitrogen. To form one bond, it required 2 electron. So these 2 electron form 1, these 2 electron will form 1, these 2 electron will form 1. So it will form what? 3 covalent bonds in between nitrogen and nitrogen. So in your lower class only you studied in your 9th standard, that is why the bond formation will be takes place means just to become stable. All elements will undergo reaction if they are ready to stable. If they will get the octet structure or completely filled structure, then only they will go to the water reaction, or else they will never form the bond. The next one, these are the some examples. In the next slide they have given so many examples. They are, you may observe, already explained, hydrogen combined with hydrogen, 2 hydrogen atoms, then it will form hydrogen molecule. In the second example you may observe fluorine, F2. So you know that one, H2, hydrogen, like that elements are, some of the elements are diatoms, F2, fluorine, atomic number 9, outermost electrons are 7. This one fluorine 7, this one also 7. This required one more electron, this one also required one more electron. Both the fluorine will never donate electron, that's why they will share the electron to form single covalent bond. In the case of oxygen atom also, here they given CO2, carbon dioxide. How the carbon dioxide is formed means carbon only outermost electrons are 4. Carbon outermost electrons are 4. So 2 oxygen means each oxygen have 6 electron. 2 oxygens will be there here. So you may observe here clearly. So 2 oxygen, here one oxygen is there, here one oxygen. So this will share the electron, 2 electron. You may observe 1, 2, 3, 4, 5, 6, 7, 8. This got the octet structure. This oxygen also 1, 2, 3, 4, 5, 6, 7, 8. This one also got the octet structure. Even carbon also got octet structure by sharing the electron. So double bond will be there. So in the same fashion, CF4, which one molecule? Carbon tetrafluorine, that is also formed what? Your covalent bond. Like that examples in your textbook they mentioned. For methane, CH4 they mentioned. Try that one in your home. Definitely you will get any one question. Draw the electron dot structure of any one molecule they will give, CO2, CH4 or ethene or ethine. Like that questions will be there in your examination. Then next we will move on to the electron dot structure of, as I earlier told, that methane CH4. Methane is what? CH4. CH4 means carbon outermost electron 4. The X indicates the carbon electron, dot indicates the hydrogen electron, CH4. Here carbon surrounding X mark is there, no, that indicates the carbon outermost electron. The dot is there, no, that indicates the hydrogen electron. So they will share the electron, they form 4 covalent bonds. Here one CH, CH, CH. Each hydrogen form the covalent bond with 4 outermost electron of carbon. Then the same way ethane molecule also, that is C2H6. 2 carbons are there. So here carbon-carbon bonding also formed. So this is all about your what? Electron dot structure. Next we will move on to the slide. Why? In your textbook they mentioned one question, that is why carbon is called as, maybe in your examination it may be arises, why carbon is called as unique element. What type of special property carbon atom have means, have to write 2 properties. Why carbon is called as unique property means no other elements will form the properties what carbon will form. 2 properties, 2 special properties carbon atom will be formed. That is, one is catenation, another one is tetravalency. Even silicon also having tetravalency. The carbon family, entire family having tetravalency, but the carbon having smaller atomic number, it will form the strongest covalent bond. How the atomic number will become less and less, the bond formation will become strong. So in the same, so why the formation of very large number of carbon compound, or else the heading will be changed like this. Why carbon is called as unique compound means one is catenation. What is meant by catenation? We will discuss. The carbon link with carbon, carbon bond with carbon itself. It may form longer chain, even it form branch chain, even it form cyclic chain. That is called as what? Catenation. Simple definition, CC bond. What is meant by catenation means the formation of CC bond up to larger, or the large CC bond will be formed. That property is called as catenation. So here what is meant by second property is tetravalency. Tetra means you know 4. The carbon have the ability to form 4 covalent bond, that is called as 4 strong covalent bond. Even silicon also form 4 covalent bonds, but carbon form 4 strong covalent bonds. That is also one of the special property. You may observe your long chain, branched chain, closed chain. So like that things are there. So we'll move on to the next one, that is hydrocarbons. We have to move on to that hydrocarbons. So the name itself indicates hydrocarbons. The name only telling the definition of hydrocarbon. The hydrocarbon is a binary mixture of hydrogen and carbon. So carbon, hydrocarbon, the binary, bi means 2. It is a mixture of carbon and hydrogen, is called as what? Hydrocarbon. Then in this hydrocarbons, here the classification is not mentioned. In your textbook also they not mentioned the classification, but one easy method is there for how the hydrocarbons are classified. Hydrocarbons are classified in such a way that 2 types: open chain, closed chain. Open chain and closed chain. In the open chain, again it divided into 2 types: saturated and unsaturated. Like that things will be there. The saturated consisting of alkane, unsaturated consisting of alkene and alkyne. The most important thing is in this case suffix ane, ene, yne, alkane, alkene, alkyne. So here hydrocarbons are the compound containing of carbon and hydrogen. They are called as hydrocarbon. So first one, saturated, they already told that. So what is meant by saturated means the compounds which are consisting of in between carbon and carbon, if the single bond is present, then it is called as saturated, or double bond or triple bond is present, then it is called as what? Unsaturated. So saturated hydrocarbons having all single covalent bond between carbon and carbon is called as saturated. The alkane is the best example. In between carbon and carbon only single bond will be present. You may observe, not in between carbon and hydrogen, only in between carbon and carbon. If the single bond is present, then it is called as saturated hydrocarbon. So as I earlier told that unsaturated hydrocarbon means it may contain double bond or triple bond. If the double bond is present, unsaturated. Triple bond is present, then it is also unsaturated. So hydrocarbon having double or triple bond is called as unsaturated hydrocarbon. Alkene having double bond, ene represent, ane represents single bond between carbon and carbon, ene represents double bond between carbon and carbon, yne represents triple bond between carbon and carbon. In such case you may observe here double bond means, so double bond for alkene. So propene also what? Double bond. Here one bond will be there. Why? Because surrounding to the carbon, definitely the motion should contain 4 bonds. Alkyne, triple bond between carbon and carbon. These are the example, ethane and propane. So next we will move on to the isomerism. As you are know that isomerism means the compound having the different types of isomerism will come, that one in your higher classes you will learn that one. But here isomerism means the compound having same chemical formula or molecular formula. Isomerism, the compounds having same or compound having organic compound especially. What is meant by organic compound? The question may arise as the compounds which contain carbon. The compounds which contain carbon, they are called as organic compound. Here isomerism means the carbon compound or organic compound having same molecular formula or same chemical formula, but different structural arrangement will be there. For the different structural arrangement or different structural formula will be there, then it is called as what? Isomers. The property is known as, or the phenomenon is called as what? Isomerism. So if the best example in textbook they mentioned, that is butane. That is normal butane. Instead of normal butane, you just write down that one as butane and isobutane. Butane chemical formula C4H10. The butane chemical formula is C4H10. If I arrange in the straight chain, then remaining all the hydrogen you have to arrange. However, name itself indicates butane, ane is there. In between carbon and carbon, single bond you have to show. Then if it is become branch, then it is called as what? Isobutane. So what is meant by isomerism? Isomerism is defined as the carbon compound or organic compound having the same molecular formula but different structural arrangement or different structural formula, then they are called as isomers. The phenomenon or the property is called as isomerism. The butane and isobutane are the two best example for that one. In your textbook, in the blue color question, they mentioned one question: write the structural formula of pentane, or write the isomers of pentane. The pentane have 3 isomers. You may observe here normal pentane, simply we call that one as pentane. Pentane chemical formula C5H12. C5H12. So carbon, if it is arranged in the straight chain, then it is called as pentane. So then if you make any one branch for the second or third carbon, then it is called as isopentane. What is the third form of pentane means isomerism form of pentane is neopentane. Each carbon or middle carbon is surrounded by 4 more carbon. One carbon is surrounded by 4 more carbon. Then each carbon is surrounded by hydrogen atom. Then it is called as what? Third isomerism form. That is what? Neopentane. There are 3 form of what? Isomerism for pentane. Pentane straight chain, isopentane branched chain, and third form is neopentane. So next thing we are going to discuss is functional group. Functional group means an atom or group of atom. An atom or group of atom which change the entire characteristics of the carbon compound. For example, here halide. Halide means halogen family, chlorine, bromine, iodine. If they change if they replace any one hydrogen with that halogen, then the entire molecule characteristics or property will get changed. That type of atoms or group of atoms are called as a functional group. An atom or group of atom which decide the property of the carbon compound is called as a functional group. There are mainly 5 types of functional group what they mentioned. That is halide, that is halogen family, that is the only prefix. Prefix means before the name we have to write that one. So if I write methane, before that one you have to write chloromethane. If chloro is there, chloro. Bromo is there means bromo. Iodo is there means iodo, like that. Then halogen. Here this one is prefix, remaining all the things are suffix. What is meant by suffix means in the alkane family, remove E, substitute that suffix. So what are the suffix will be there, and what are the functional group for these things means alcohol indicated with OH. Alcohol indicated with OH. Suppose CH3OH is methane. Actually carbon naming, nomenclature naming will be decided by the number of carbon. We have to count the number of carbon. How the nomenclature will be done means we have to count the number of carbon. The naming will decided with the number of carbon. Then we have to go for functional group. Then we have to go for it is alkane or alkene or alkene. So alcohol functional group is OH. Its suffix is OL. Aldehyde functional group is CHO. Its suffix is AL. Carboxylic acid, its functional group is COOH, but its suffix is oic acid. OIC acid, oic acid. Then last one is ketone. Ketone functional group is CO or C double bond O. Its suffix IL. 1, ONE 1, remove E and we have to write 1. So this is a small introduction to your what? Functional group. One by one I will explain. First one, if I take alcohol, methane, CH4, in that one replace one hydrogen with OH, then it will become CH3OH. You may observe here. Then the name become, the naming decided by the number of carbon, it is methane. We have to write methane. But the functional group in that case is OH. That is what? Alcohol. Then replace E with OL. Then the name changed to methanol. Actually methane, that is one carbon. Then that replaced E replaced with OL. Why OL means the functional group attached in this case is alcohol. In the same fashion we have written that ethanol. The next one aldehyde. Aldehyde it starts with methanol. Only one carbon is there, CHO. Hydrogen is there, methanol. For the methane, if I replace one hydrogen, CH4 is there. If I replace one hydrogen with CH4, CHO functional group, then the name is, we have to count number of carbon, 1 and 2 carbon. If for the 2 carbon, the name is ethane. but the number of carbon 2 means ethane, but functional group attached to this one is CHO, that is aldehyde. Aldehyde suffix is replace E with Al, then the name is ethanol. The next one is carboxylic acid. How I substituted the name, like that only, we have to count the number of carbon, then write its suffix. So for only for halides we have to write what? Prefix. So here one hydrogen in the methane, CH4, one hydrogen is replaced with chlorine, then the name is chloromethane. For that one bromomethane, C2H6 is ethane. In that one hydrogen is replaced with bromine or chlorine. If I replace with chlorine, then the name is chloromethane. If I replace that hydrogen with bromine, then the name is bromoethane. So like that ketone also we have to count the number of carbon. Here also we replaced E with 1. We have counted the number of carbon 1, 2, 3. 3 carbon propane we are replaced. Then it become what? Propane, but replace E with 1, propanone. Like that butanol also came. Now we will move on to the next one, homologous series. It may be in your examination for 2 or 1 or 2 marks it will be there. So what is meant by homologous series means, homologous series is defined as series of organic compound, having similar chemical property, and similar structures, but successive member difference is CH2, one member to next member. For example, methane CH4, next member is ethane C2H6. So one member to methane to ethane, what increased means CH2. Here to here difference is 1 carbon increased, 2 hydrogen. The successive member, one member to next member difference motion should be CH2, then only it is called as what? Homologous series. What I explained in the functional group case, methanol, ethanol, propanol, there is also example of homologous series. Methanol, ethanol, propanol, that is also what? Example of your homologous series. So methanoic acid, methanoic acid, ethanoic acid, propanoic acid, that is also one of the example of homologous series. So homologous series is a group of or series of carbon compounds or series of organic compounds having similar structure and similar chemical property. Only one thing is the successive member difference is what? CH2. They are called as homologous series. The best example for this one is alkane, alkene and alkyne. Let us start with the first example, alkane. Alkane means, already we discussed, alkane means having single bond, that is saturated one, single bond between carbon and carbon. Its general formula is CnH2n plus 2, CnH2n plus 2. So n is indicates the number of carbon atom. N indicates what we have to write. The n is any natural number you have to take. If I take 1, if I take any 1, if I started with 1, so then carbon will become in this formula, if I substitute 1, C1H, 2 into 1, 2, 2 plus 2, 4, then it becomes CH4. If I take number of carbon 2, that is natural number 2, N, if I substitute N 2 carbon, ethane. Monkey eats peeled banana. Monkey, M means methane, E eats ethane, peeled, P means propane, banana, butane. Like that, easy to remember that methane, ethane, propane, butane. Monkey eats peeled banana. 4 members are enough. 4 to 5 members of the family of alkane, alkene, alkyne are enough to study, are enough for your examination purpose. So this is your propane. If I replace N with 3, number of carbon 3, then propa. So 3 in that formula, 2N plus 2 is there, no? 2, 3 are 6, 6 plus 2, 8. Like that I have written. These are the structure of methane. In between carbon and carbon, single bond, make one catenation chain, straight chain. In between carbon and carbon, how many carbons are there? For example, pentane, 5 carbons are there. Pentane, 5 carbons are there. Then we have to write C. In between carbon and carbon, single bond. Then remaining hydrogen, 12 hydrogens are there. Just arrange for each carbon 4 bond. Then you will get the structure of a pentane. The next homologous series is alkene. Alkene having double bond. It is an unsaturated double bond between carbon and carbon, having general formula CnH2n. So CnH2n, same what I told. N is any natural number. You have to start with 1. If I start 1, it is not possible. If I take 1, C1H2 will be there. 2 into 1, it will become methane, but methane is not stable, it is not supposed to exist on the earth, it is not possible, it will not satisfy the valency of carbon, so it is not present exist in the earth. But the alkene family starts with ethene, so C2, then it will become H, number of carbon 2, then C2, N value is 2, 2 2s are 4. Ethene chemical formula C2H4. Then propene, if I substitute, propa means 3 carbon, then 3 2s are 6, 3 3H6. In the same fashion butene and pentene. So here structure also very easy. So here ethene, already ethene, ENE represent double bond, alkene represent double bond, C2H4 is there, write 2 carbon, then make double bond between carbon and carbon. Why we are making the double bond between carbon and carbon means, so it is what? Alkene, unsaturated. Double bond means alkene is there, so remaining hydrogen you arrange for each carbon 2 hydrogen, then the structure of ethene you will get. Then propene, so propene means C3H6 is there, so CCC, 3 carbons you have to write, 3 carbons, carbon CCC, then remaining thing you have to write, make any one side double bond in between any 2 carbon, make one double bond, then remaining hydrogen you have to arrange. The 6 hydrogens are left, no, that arrange, if I arrange that 6 hydrogen according to for each carbon 4 bond, then you will get what? Propene structure. Then in the same fashion you will get that butene. So then after completion of butene, alkynes will be there. Alkyne having the general formula CnH2n minus 2. Alkyne general formula CnH2n minus 2, having triple bond between carbon and carbon. If the triple bond between carbon and carbon is there, then it is said to be what? Then the triple bond present between carbon and carbon, then it is said to be alkynes. Yne, the suffix is what? Yne. So here it is also start with the number of carbon 2, ethyne. So ethyne general formula, if I substitute 2 here, natural numbers, N value 2, C2, 2 2s are 4, 4 minus 2, 2. We will get ethine as C2H2, propane as C3H4, butane as C4H6. Like that you will get. Here you may observe ethyne C2H2, write 2 carbon. Why? Because ethyne C2H2 is there, write 2 carbon, in between carbon make triple bond. Why we are making triple bond means Yne. Yne indicates triple bond. So triple bond after, then it will be what? Hydrogen and hydrogen. So in the same fashion we done propane and butane. So among that things you need to remember all alkane, alkene, alkyne. Why that much of important alkane, alkene, alkyne means to write the functional group. To well understanding of that functional group, that alkane family, alkene family and alkyne family, it must and should be there in your mind. So now the most important part of the chapter, chemical properties of carbon compound. There are 4 chemical properties are there. Among 4 properties, one will be there in your examination for 2 marks. So what are the 4 chemical property means? First chemical property is combustion. The meaning of combustion itself indicates what? Burning. So carbon compounds, and the introduction only I told the fuels what they all are carbon compound. The carbon compounds, if they burn with the presence of oxygen, your carbon burns with oxygen, it forms carbon dioxide, it liberates heat and light. So methane burns with oxygen, then it forms whatever the things, whatever the carbon compounds are, if they burn in the presence of oxygen, they form what? Water and carbon dioxide. They liberates heat and light energy. So here for the combustion, carbon compounds burn in the presence of oxygen, but one more thing will be there in your examination, that is incomplete combustion. What is meant by incomplete combustion means, if the insufficient oxygen is available for these carbon, methane and ethanol, if the insufficient oxygen, if these compounds are undergo combustion, then the product is not formed carbon dioxide, the product formed is carbon monoxide, not CO2, it forms CO. Then it is what? Harmful to our environment. So that is also one of the thing in that combustion case. During complete combustion, it gives blue flame. If that fuel is completely burned in the sufficient oxygen, then it will give blue flame. If it is burned in incomplete or insufficient oxygen, then it gives yellow flame. Then second chemical property is oxidation. So you have to read this combustion along with that chemical reaction, you must should be perfect. Then second one is oxidation. Oxidation means already you studied in the first chapter, addition of oxygen. So for this reason we required ethanol is there, C2H5OH, ethanol. So how we named means you already know number of carbon 2, then the ethane, OH functional group is there, ethane, remove E, OH alcohol functional group, substitute E with OL, this will the name become what? Ethanol. Ethanol is converted into ethanoic acid. You may observe here C2H5OH is there. Here the ethanol in the presence of ethanol react with in the presence of alkaline KMNO4, potassium permanganate or potassium dichromate, alkaline potassium permanganate or acidic potassium dichromate. Among these two, both are what? Oxidizing agent. KMNO4 and K2Cr2O7 are oxidizing agent. When ethanol react with alkaline KMNO4 or acidic K2Cr2O7, then that ethanol is converted into ethanoic acid. Here only one oxygen is there, here two oxygen are came, then the addition of oxygen is known as what? Oxidations. So simple oxidation what you written in the first chapter, that is different, here different. Why? Because here addition of oxygen over, but the thing is very important is ethanol is converted into what? Ethanoic acid. Ethanol is converted into what? Ethanoic acid. That is the one of the important thing. We will move on to the next one. Chemical property is addition reaction. So as we discussed in the two chemical reaction, one is oxidation. So first one is combustion, second one is oxidation. The third chemical reaction of the carbon compound is addition reaction. The name itself indicates addition. So adding of hydrogen for the unsaturated compounds are converted into saturated. For the unsaturated component are converted into saturated. See, for example, here C2H4 is there. This one is nothing but what? Ethene. Ethene is unsaturated one. When this ethene react with one hydrogen or one molecule of hydrogen, ethene react with hydrogen in the presence of nickel or palladium as catalyst. You know what is meant by catalyst, which increases the rate of reaction. So what is meant by addition reaction means adding of hydrogen to the unsaturated hydrocarbon to convert them into saturated hydrocarbons is nothing but what? Addition reaction. In this addition reaction, what are the catalysts we used is nickel or palladium we need to use. See here ethene, when it is react with hydrogen in the presence of nickel and palladium, it converted into ethane. Unsaturated ethene converted into saturated ethane. In the same fashion, one more example you may write, that is ethyne. So ethyne having C2H2, ethyne having what? C2H2. When ethyne C2H2, it is also react with hydrogen, it required two hydrogen molecule, that is total 4 hydrogen, 2 molecule of hydrogen. If they react in the presence of nickel and palladium, then that ethyne is converted into what? Ethane. For ethene to ethane, only one hydrogen molecule is required, that is H2. But ethyne to ethane, two H2 molecules are required. Two H2 molecules are required to convert ethane into ethane. That is the one of the third chemical property of your carbon. Then fourth and last chemical property of the carbon is, that is substitution reaction. Substitution means here each hydrogen is replaced with one chlorine atom. So for example, when methane react with chlorine in the presence of typical UV light, you may write that UV light or typical UV light or typical sunlight you may write. So substitution reaction means the name itself indicates substitution. So hydrogen is substituted with one chlorine. You may observe here the reaction CH4 react with chlorine, it forms chloromethane. Here one hydrogen, CH4 consisting of 4 hydrogen, then one hydrogen is replaced with one chlorine molecule, then it becomes CH3. Then in that hydrogen place chlorine is added, then it called CH3Cl, chloromethane. The reaction is not stop here only, the reaction will continue up to the replacement of all the hydrogen from that methane. So you may observe here the product formed is chloromethane. Again chloromethane react with chlorine, chloromethane react with chlorine. So again in the presence of same typical sunlight or UV light, then one more hydrogen is replaced, then one more hydrogen replaced with chlorine means CH3Cl is there plus Cl2, then hydrogen is replaced, then CH2, then one chlorine is added to this one, then it will become CH2Cl2. This is the fourth important chemical property. Among four chemical property, one will be there in your examination. Try to remember these four chemical property: combustion, the burning. Second one is oxidation reaction. Oxidation means in that one oxidizing agents will be there, KMnO4 and K2Cr2O7. Then addition reaction, catalyst will be there, then catalyst are nickel and palladium. So then last one is substitution reaction. Here each hydrogen is substituted with the chlorine atom. These are the four chemical properties. Then next we will move on to the some important carbon compounds. There are two important chemical compounds they mentioned in your textbook. That is, one is ethanol. Second important chemical compound they mentioned is ethanoic acid. Among two, definitely one will be there in your examination. Why? Because only two carbon compounds are they given. One is ethanol. When the name is ethanol, the general name of ethanol is, generally we call ethanol as alcohol. Generally we call that ethanol as alcohol. Its chemical formula C2H5OH. We call that one as ethyl alcohol. You may call that one as ethanol. You may call that one as ethyl alcohol. You may generally call that one as alcohol. It is the active ingredient of all the alcoholic drinks. The drinks what they will be supply in the bar and restaurants, their active ingredient is what? Ethanol itself. So first we will learn that the properties of the ethanol. The properties, as I told, ethanol is the colorless liquid with a pleasant smell, okay, and burning taste. For that, this outer skin, it will give the cooling effect. For the internal skin, for the internal organs, it will give the what? Burning effect will be there. So it has pleasant smell. Then second one, it is highly soluble in water. It can easily soluble in water. Then the third most important property is ethanol react with sodium. So you may observe ethanol react with sodium. It form sodium ethoxide and hydrogen gas will be liberated. So sodium react with water, ethanol, or ethanol react with sodium. It forms what? Sodium ethoxide, and also it liberates hydrogen gas. Then we will come to the fourth property. So ethanol in the presence of concentrated sulfuric acid. If suppose only two reactions are mentioned for ethanol. One is ethanol react with sodium, it forms sodium ethoxide. So second reaction is, so when the ethanol react in the presence of concentrated sulfuric acid, here one thing you have to know, concentrated sulfuric acid is known as dehydrating agent. It will remove the water molecule from ethanol, then the compound formed is C2H2. Ethanol is converted into ethane. Ethanol is converted into ethane. This H2O is absorbed by that concentrated sulfuric acid. So these two reactions you must should remember for your exam purpose. Then last but not least, that uses of the ethanol is used for making of the alcoholic drinks. In the early only I told. So it is used as a solvent for so many medicines are dissolved in this ethanol only. Then last one, it is used to medicine like a tincture of iodine and cough syrups and tonics. These all contain what? Ethanol. If the question arises for 1 mark, write the use of ethanol means, just write down ethanol is the active ingredient of the alcoholic drinks. Then it is used as used in the tincture of iodine, and also it is used in so many tonics. So this completes your what? Ethanol. Then next we will move on to the second important chemical compound, that is carbon chemical compound, ethanoic acid. Ethanoic acid is also known as, generally we call this one as vinegar. Generally we call this one as vinegar. We call this one as acetic acid also, CH3COOH. It is also called as vinegar, or it is also called as what? Acetic acid. What are the properties? Let us start with the properties. First property, ethanoic acid is colorless liquid and having pungent smell and sour to taste. It is acid. You studied in your lower class, acids are sour to taste. That's why it is having sour taste. Then second one is, it is soluble in water like ethanol. Ethanoic acid also easily soluble in water. Then the third one, if you take 5 to 8% of ethanoic acid or acetic acid, then that solution is known as vinegar. In a 1 liter of water bottle, if you added 5 to or 50 to 80 ml of 52, that is 5 to 8%, 50 to 80 ml of ethanoic acid if you mix, then that solution is known as what? Vinegar. It will give the sour taste for the food. The vinegar is used in the water in our day-to-day life, especially in kitchen we will use that vinegar. Then in this case the first reaction will start with esterification. So define esterification. Question will be there in your previous questions paper. They asked define esterification, write one example. Esterification means what we studied, ethanol and ethanoic acid. Esterification is defined as ethanol and ethanoic acid both are combined, then it is called as what? Esterification. Here ethanoic acid react with ethanol, one acid react with one alcohol, acid react with alcohol, then they form what? Ester. Then that phenomenon is known as what? Esterification. So you may observe here reaction, that is acetic acid or ethanoic acid react with ethanol in the presence of concentrated sulfuric acid, then the product formed is ester. You may observe COO indicates the water ester. How we are going to indicate that one only? Ester means it must and should present COO, then it is water ester. So it forms ester, then the reaction between carbonic acid and alcohol is known as ester. So let it. In this one, second one is saponification. Here what ester is formed, you may observe here CH3COO C2H5, that ester what they are formed, that will be react with sodium hydroxide. What is meant by saponification we are telling? So when the ester react with sodium hydroxide, it is a base, strong base. Sodium hydroxide is a strong base. When this ester react with, that is nothing but CH3COO C2H5, when this ester react with a strong base like sodium hydroxide, it form what? Sodium acetate. Sodium acetate, and you will get that ethanol back. So this one is formed when the ethanol and ethanoic acid are combined. This one is formed. When this one react with, the ester is react with sodium hydroxide, then the product formed is what? Sodium acetate, and your ethanol is formed. So in the same way, what is the importance of these things? The ethanoic sodium acetate, what we studied, sodium acetate, it is also formed with the help of directly ethanol react, directly your ethanoic acid react with base, then also it forms. So your ethanoic acid react with sodium carbonate and sodium bicarbonate, then also it forms what? Sodium acetate. So dear students, here 4 times sodium acetate, sodium acetate, sodium acetate, sodium acetate, 4 times the product is formed. In your textbook also you may observe these 4 reaction. Why that times of sodium acetate is formed? Why we are preparing sodium acetate with the ester? Why we are preparing the sodium acetate only with the ethanoic acid? Why we are forming that one with a base like sodium hydroxide, sodium carbonate and sodium bicarbonate? Means this is the nothing but, this one is nothing but the sodium acetate, what it is formed, that is nothing but your soap. The soaps what we are using in our day-to-day life, that is nothing but what? Sodium acetate. That is the CH3COO Na. That is nothing but what? Your soap what we are using in our day-to-day life. So this is all about your ethanoic acid. One more important thing here, what are the uses of esters? Why we added ethanol and ethanoic acid? So when we added ethanol and ethanoic acid, then the product formed is ester. What is the use of ester? Means ester is used in our, it is a sweet smelling substance. The ester is what? Sweet smelling substance. To make perfumes, we will use what? Esters. So these are the 2 important chemical compounds which we learned in this class, that is ethanol and ethanoic acid. Then the last bit of the chapter, that is soap and detergent. Soaps and detergent. What are soap means? What are soap means? Soaps are the long chain sodium. Soaps are what? Long chain sodium or potassium salts of carboxylic acid. As I earlier told that. So you studied that one. C2H5COO. What? C2H5COO. That CH3 is there, no? The same molecule. Here sodium stearate is the one of the best example. Here what sodium came. Sodium acetate is, I already told, sodium acetate is called CH3COO Na is soap, as I earlier told that that is also soap. CH3COO Na, it is also soap, but it is long chain. In that CH3 place, if C17H35K means C17H35, long chain, the carbon chain become long chain, then it is called as soap. Soaps are the long chain. In this case, either it may be sodium or potassium. If we replace that Na with K, then it will become potassium. So long chain sodium or potassium salts of the carboxylic acids are called as what? Soaps. This is the structure of soap. You may observe here Na and C. The soap having sodium acetate having two ends, two terminals will be there. One is hydrophilic, another one is hydrophobic. So hydrophilic means water, it definitely it react with water. Hydrophobic means it has fear of, phobia means fear of that water. So it has two end, one carbon end, one is ionic end. So carbon end react with the dirt. Almost all dirt is here. The question will be there, students, for 2 marks. Explain action of soap. Explain action of soap. When the explain action of soap means soap action will be on dirt. Almost all dirt is oily in nature. So water never react with oil. So when we use the soap has, I already told, soap has two ends. So one is carbon end, another one is ionic end. That ionic end will be here, will be there. So ionic end react with water. Then it forms water foam. Lather it will be formed, but the carbon end react with the dirt. Then finally it forms micelles. MICELLES. It will form water micelles. These micelles are helps to remove the water dirt present on the cloth. If the cloth contain any dirt is oily in nature, the carbon end on the dirt, only carbon part will be react. The ionic end will react with the water. So this is your water cleaning action of the soap. For the cleaning action of the soap, micelles or motion should be there. So the next one is, so here you may observe soap, micelles will be there. So sodium end is what? Ionic end. It react with water. This end is called as carbon end. This one end is called as what? Carbon end. Then the dirt particle, you may observe, this one is dirt particle. With the dirt particle is obviously oily in nature or grease in nature. So this carbon end react with the water, only react with the dirt particle. The sodium end react with the water. Total it forms react with the water, then it forms emulsion. Finally it will helps to remove the water dirt from the cloth. So this is your cleaning action of the soap. If the question is arise for the 2 marks means you have to write the definition of soap. Long chain hydrocarbon of any sodium or potassium is called as water, is called as soap. Then next one you have to write how that soap consisting of two ends, one end react with water, one other one react with soap, then it finally forms emulsion. It helps to remove the dirt, means you will get your 2 marks. Then the last one, that is detergent. What are detergent mean? Detergents are the long chain. They are also long chain soap, but they are long chain sodium salt. They are also sodium salt, but sodium salt of sulfonic acid. They are the water long chain sodium salt of water sulfonic acids. They are called as water detergents. So what is the difference between soaps and detergent? It means soaps do not wash, or soaps will never give much lather with hard water. If I add soap in the hard water, it never give lather, but detergents will give more lather with the hard water. That is the main difference between soaps and detergent. So detergent will be react with hard water, they will form water huge quantity of lather. It forms insoluble precipitate that doesn't form insoluble precipitate. That is also one of the important thing. Then finally the difference between soaps and detergent is soaps are sodium salts of fatty acid. They are made up of animal and fat oils, but detergents are sodium salts of sulfonic acid. Soaps clean well in soft water, detergent clean well in both soft water and hard water. Soaps do not clean as well as as well as detergent. Soaps do not clean. So if I wash the cloth with soaps and detergents will give the more cleanliness, but detergents are better than soaps. Then soaps are biodegradable, do not cause us any pollution. The most important thing is this one only. So detergent causes what? Most of the biodegradable, it is non-biodegradable, it will not undergo any decay easily. So this is all about your what? Carbon and its compound chapter. Dear students, in this carbon and its compound chapter, we started the carbon and its compound chapter with the introduction of the carbon, where it is present, carbon where it is present. Then after completion of this one, carbon, the chemical properties are important in this one. Combustion, what I told, combustion, oxidation, addition reaction, then last one is substitution reaction. Along with this one, you have to know the how to write the functional group and how to name the compound, Then finally the action of soap, also one of the important thing in this chapter. If you are preparing, already you studied this one in your school, this is then just an revision class. Try to read that entire chapter 1 or 2 times, better to prepare for your examination in this lockdown situation. Thank you.